Are there any questions?
It was just on a test, I was trying to figure out how to, on the second problem, how to cancel out L for,
I got what's the electric field strength at a radius of 0.2. Let's see, long annular cylinder.
I just kind of forgot exactly how to do it. And I derived the other formula to try to get or for the,
Would you like me to just
Sigma.
tackle it? It seems like you're struggling to come up with something more specific, so do we just start and you'll...
The only thing I have issues with is canceling out the length in the derivation formula
Okay.
we needed.
Yeah.
I didn't know how to do that.
So we have a volume charge density. What we care about is the charge inside. So doing Gauss's law. Seems like you do end up with a chargeable length. Let's see. So we end up with phi is equal to the enclosed charge over epsilon sub naught. We have the annular cylinder, and we are here, 0.2. Yeah, it was 0.21 meters. This was 0.18 meters and 0.25. Pretty sure. I know that the electric field, so the charge that's within my cylinder here, my Gaussian cylinder, is going to be pi times 0.21 squared L minus pi 0.18 squared L So that's the volume times the volume density times rho. So that would be the charge inside. And that would be equal to, oh, okay. So I know the electric flux is E times A. If you're picturing a cylinder, the end caps, by symmetry, I know that the electric field is going away from the core, the central line. The electric field also, there's no reason, because of symmetry also, the electric field should have the same magnitude, same strength anywhere along this line. And so my surface area of the sides here, try that again. My end caps will have no flux through them because the electric field is perpendicular to the area. Area vector being this way and that way. Here, my area vector is in the same direction as the electric field. So E times A will be E times the area of the cylinder, which is 2 pi 0.21 L. And that's going to be equal to this.
Okay, yeah, that's
the
where
other cancel.
that was converting EA to the surface area was, that's why I couldn't cancel out the L's. I
Okay.
couldn't get it. Thank you.
Yep.
Is that the only way you can get the correct answer?
I would not think so. You probably also, if the sphere, yeah, so the electric field from a line of charge of uniform density is 2K lambda over R. That's the electric field strength. So if you remember that formula. Lambda would be, we basically have to convert that volumetric density into a linear density. So we have charge divided by the length. So L would cancel out at that point. So that would be the charge per length. So that's lambda. R would be 0.21. K is 9 times 10 to the 9th. That should come up with the same answer.
Okay.
And there are probably other ways of doing it too.
On master set 25, one of the questions was a plane, and then there were two vectors, and one went one way and the other went the other way. And I ended up with a negative answer.
For the flux?
Yes. Should the flux always be positive?
No, it can be negative.
But if you like switch which way was positive, that could be the same value but positive.
Yes.
So both answers are fine.
If it's an open surface, then yes, both answers are fine. You know, one or the other, pick one.
So don't write plus or minus?
Correct, don't do plus or minus.
Okay.
Commit to the direction of the area vector and stick with it. And if someone says otherwise, just shout them down. No, you're wrong. Except louder. And then pull out your switchblade. It still amuses me to think of Einstein and, well, Einstein in a knife fight. Probably just me. There's an alternate history book that I got, and on the cover of it was Gandhi with Rambo-type muscles holding a machine gun, or a flamethrower, one or the other.
Why was that?
Why?
Do you know why that was the cover from reading it?
It was, yeah, what it was is if Gandhi had chosen the cult of Kali as opposed to the path he did take, he would have been a killer instead. He was not using a machine gun or a flamethrower. Cult of Kali? I don't know if cult's the right term for that. I don't know how many followers they have.